Hello, dear students. We were studying Chapter 9, Force and Laws of Motion, in which we have already studied Newton's first law and second law. Now, today we are going to study Newton's third law of motion. According to Newton's third law of motion, every action has equal and opposite reaction. These action and reaction forces are equal and opposite but act on two different bodies. So you have to learn this. For every action, there is equal and opposite reaction. Now some applications of Newton's third law of motion. In our day-to-day life, we come across many examples, like when we jump out of the boat in the forward direction, the boat moves in the backward direction. We are moving in the forward direction, that is the action, and the boat moving in backward direction is reaction. These two forces are equal and opposite. Now, if you take a blown balloon and release it, the air rushes out downward where the balloon goes to the upward direction. So the air rushes downward is action and balloon goes up is reaction. Both are in opposite direction. So you can watch this video and see more example of Newton's third law of motion. Now, watch the video.
We are going to study the applications of Newton's third law. Action and reaction are involved in walking. When we walk on ground, we push the ground backwards. This force of a push is called action. As you can see here, when we walk, we apply action on the earth. Simultaneously the ground applies an equal and opposite force on our feet. We call this force as reaction force. It is the force of reaction of the ground on us which enables us to walk on ground. So in this way action and reaction are involved in walking. Thus Newton's third law helps us in walking. Recoiling of gun. When the bullet is fired, a force of action acts on the bullet, and equal and opposite force, that is reaction, acts on the gun, which makes the gun move backwards. So this is the action, and the gun receives the reaction in the opposite direction. Since mass of the gun is much greater than mass of bullet, hence the velocity of gun in backward direction is much less than the velocity of bullet in the forward direction. That's why a gunman is advised to tightly hold the gun to the shoulders. When a bullet is fired from the gun moves backwards. This is called the recoiling of the gun. Swimming. During swimming the person pushes the water backwards, by hand. That is our action. Simultaneously, water applies an equal force in forward direction. That is our reaction, which enables the person to swim. So in this way, swimming also involves some action and reaction pairs. Jumping of man out of boat. When a man jumps out of the boat, he applies some force on the boat, in backward direction. Thus it is its action. The boat is pushed away from the bank due to action of the man on it, as you can see here in this figure. And the man jumps out on the boat, due to the reaction of the boat on him. Motion of rocket. Action of gases gives reaction on the rocket, which moves it forward. So these all are the applications of Newton's third law. In world, many more applications of Newton's third law are in our day-to-day life.
There are many more applications of Newton's third law of motion given in your NCERT book also. Read the book and I hope you are now able to understand these applications. Now, law of conservation of momentum. The total momentum of an isolated system is conserved. Isolated system means no external force on the system. It means that in a system, if no external force is applied, then the total momentum of the system remain conserved. This we can prove mathematically. So mathematical formulation of conservation of momentum. For that, suppose we have taken two objects A and B. They are moving in a straight line in the same direction, and the velocity of A is greater than velocity of B. Let the initial velocity of A be u1 and the initial velocity of B be u2. The mass of A m1 and mass of B m2. So these two bodies collide for t seconds, and after collision they are moving with velocity v1 and v2 respectively. Then we know that momentum is mass into velocity. So therefore momentum of A before collision m1 u1 and momentum of B before collision m2 u2. And momentum after collision m1 v1, momentum after collision of B m2 v2. So we know that the force is rate of change of momentum, and mass into change in velocity upon time, this is the force. So momentum, a rate of change of momentum for body A, force due to A on B, FAB is m1 v1 minus u1 upon t. Similarly, rate of change of momentum of body B, that is force of B due on A, is equal to m2 v2 minus u2 upon t. Now, we know that according to Newton's third law of motion, action of object A is equal to reaction of object B, but in opposite direction. So, FAB is equal to minus FBA. Putting the values here, FAB is m1 v1 minus u1 upon t, and FBA is m2 v2 minus u2 upon t. So cancel out t from both sides, you will get this expression, and after simplifying you are getting m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This means that the total momentum of object A and B before collision is equal to total momentum of object A and B after collision. So this verifies law of conservation of momentum. So this is important point, that there should not be any external force acting on an isolated system. So isolated system means there is no external force acting on both the bodies. So recoiling of gun can also be understood by law of conservation of momentum, which you have seen in the application of Newton's third law also. Recoiling of gun means when the bullet is moved in forward direction, the gun moves in the backward direction. This is called recoiling of gun. So the momentum of the bullet gun system is conserved. That is, the momentum before firing was 0. So momentum after firing of the gun bullet system must be 0. That is, the momentum of bullet is equal to momentum of gun, but in opposite direction. So we can find the velocity of recoiling of gun using this law of conservation of momentum. So here is one numerical. Find the recoiling velocity of gun having mass equal to 5 kg if a bullet of 25 gram acquired the velocity of 500 meter per second after firing from the gun. So here the values are given. Mass of bullet 25 gram converted into SI unit, that is kg. So 0.25 kg. Velocity of bullet before firing u1 equals to 0. Velocity of bullet after firing V1 equals to 500 meter per second. Mass of gun 5 kg. And velocity of gun before firing 0 and velocity of gun after firing we have to find. So we know that by law of conservation of momentum, m1u1 plus m2u2 is equal to m1v1 plus m2v2. So putting the values here, left hand side will be 0 as the velocity u1, u2 both equals to 0. And right hand side m1v1 is plus m2v2. So is total equals to 0. So after firing, m1v1 is equal to minus m2v2. From this we can find v2. So v2 is equals to minus 2.5 meter per second. So in this way you can solve all the problem of law of conservation of momentum also. If you have any doubt, you can ask me.